A stone is thrown vertically upwards with initial velocity u meter per second. It reaches a maximum height and returns to the ground. Find an expression for number I, the maximum height. Number I, the velocity on hitting the ground. So this is how to solve it, okay? This is how to solve this question, okay? Now let us use this formula. V squared equals to u squared plus 2as. You know, this question is still motion under the gravity, okay? Now using this formula, v stands for final velocity, u stands for initial velocity, a stands for acceleration, and s stands for distance or height, okay? And the question says a stone is thrown up vertically, okay? It's thrown up vertically. That means it is against gravity. Now this acceleration will become a equals to minus g. So it will be minus g because it is against the gravity, okay? So now we replace this with this one. We now have v squared equals to u squared plus, it won't be plus now when we insert this one, it will now be a minus 2gs, okay? Okay, it will now be this. Now you know we are finding the expression, right? Now from the question, they have given us initial velocity to be u meter per second, right? Now they are asking us the maximum height. We should find the expression for the maximum height. That means if to say they have given us number, it means that we should calculate for the maximum height. Now let's find the expression for the maximum height, okay? Now s should stand for the maximum height. Let s equals to h, okay? Now we replace this s to be h. We replace s to be h, right? For our maximum height. Okay, now at the maximum height, remember, you thrown a stone upward. At the maximum height, the stone will stop before coming down. When it reaches the maximum height, it will temporarily stop there before coming down. So now, as it has been thrown upward with the initial velocity u, when it reaches at the maximum height, the final velocity there will be 0, right? The final velocity will be 0. Now the final velocity will be 0, which is equals to u squared minus 2gh, which is the maximum height. Now taking this to this side, it will now be 2gh equals to u squared, making our h subject of formula, which is the maximum height we are looking for, to now be h equals to u squared all over 2g. This is the expression they are asking us. So if to say numbers are assigned to u and the g, which may be approximately 10 meters per second square, you now fix the number and get the value of the highest height. So that's how to find the expression they ask us. And they still tell us to find the expression for the velocity on hitting the ground. For the velocity on hitting the ground, we will still use the same formula, which says v squared equals to u squared plus 2as. In this case now, our acceleration now is going the same. You know, the stone reaches to the maximum height, it will temporarily stop before coming down. The acceleration now will now go in the same direction with the gravity. And the stone is now moving with the same direction, okay, with the gravity. So our A now will now be G, positive G, no longer minus. Minus is when it's going against gravity, but now it's going in the same direction with gravity, so it won't be minus again. And our S will now be the maximum height, okay. Now what they ask us now is the velocity while hitting the ground. Now we will still have our formula. V squared equals to U squared plus 2 to 9 be G. Now G height, which is the highest height, right? Now remember, when it reaches the highest height, it will temporarily stop before coming down. It will temporarily stop before coming down. Now when it stops now, it starts coming down. So now you know what is a two-way thing, is a two journey things. Going up one and coming down two. So while going up reaches to the highest height, it will temporarily stop and start coming down. Now let us take the journey of coming down. When it starts coming down now, the initial velocity will now be 0, right? The initial velocity, because that time it stopped, it will now be the initial velocity before start coming down, and then it will now gain velocity as a result of the gravity while it is coming down until it hits ground. So the final velocity will now be the velocity it used to hit ground, while initial velocity will now be that 0 when it temporarily stopped before coming down, right? So get me, we now have V squared, which is the one we are calculating for, that velocity is used to touch ground, equals to U, which will now be 0 initial velocity, okay, plus 2G height, right? So now you see it now. Now taking away the 0, we now have V squared equals to T 2G height. Now making V subject of formula, right? We now have V equals to square root 2GH. That is the expression they're asking us. Please, I still beg you to subscribe to my YouTube channel. Follow me on Facebook. Thank you so much. Thank you for watching.